In problem number 3, we have the graph of velocity v of t in feet per second of a car traveling on a straight road for t between 0 and 50 inclusive, shown above, and a table of values for v of t at 5-second intervals of time t is shown to the right of the graph. Question A says, or asks, during what time intervals, or during what intervals of time is the acceleration of the car positive? Give a reason for your answer. And I simply state that acceleration is positive when v of t increases, and that will happen between 0 time t equals 0 to 35, or for time between 45 and 50. So that is part A. Part B, find the average acceleration of the car in feet per second squared over the interval from 0 to 50 seconds. Now, since we're working with a velocity here, acceleration would be the rate of change of velocity, and so we're asked for the average rate of change of velocity, and the average rate of change of a function is just the slope of the secant line connecting the endpoints. So all we need to do for B is find that slope, and it'll be v of 50 minus v of 0 over 50, and that is 72 over 50, or 1.44 feet per second squared. For part C, we're asked to find one approximation for the acceleration of the car. Again, since this is velocity, acceleration will be the slope of the tangent line to the velocity curve. Now, since we don't have a function, we can't algebraically determine what the derivative is, but the easiest way to do this will be to find 2 points that give a good approximation for the slope at times t equal 40. So we'll use instead 35 and 45. It's very common, use 1 point to the left, 1 to the right, and although it may not be exact, it will be a fairly close approximation of the tangent to the curve at t equals 40. And so we find that by v of 45 minus v of 35 over 10, which is 60 minus 81 over 10, which comes out to be negative 2.1 feet per second squared. Right? So we'll go on to part D. Approximate the integral from 0 to 50 of v of t dt with a Riemann sum. The integral of v of t dt is just the area under the velocity curve from 0 to 50. Approximating it with a Riemann sum just means to use rectangular areas, and for those rectangular areas we're going to use the midpoint of each of 5 subintervals of equal length as the height of the respective rectangles. So one of the first things that I will do is to kind of delineate the subintervals there, and so I have there 5 subintervals of equal width, and the height in each one of those is going to produce a rectangle. The height of each rectangle is going to be the value of the function at the midpoint of that subinterval. So that will be the height of the function at 5, at 15, at 25, at 35, then at 45. So those will be the heights. And I can draw in those rectangular areas there. You can see that the area of all of those rectangles combined together would give a fairly accurate approximation of the area under the curve and hence the integral. Well, each of those areas has a width of 10, so I can factor out that width of 10, and I can say that the integral from 0 to 50 of v of t dt is approximately equal to 10 times 12 plus 30 plus 70 plus 81 plus 60, and I've also written the area of each of those rectangular regions on the graph itself, and that comes out to be 2,530 feet. And we want to explain the meaning of this integral, and that is the distance traveled by the car in the first 50 seconds. And that will do it for this problem.